Hey, this is Kim Breeden at Minnesota Online High School. In this video, we're going to learn how to solve systems of linear equations graphically. So first off, what is a system of equations? Well, a system is just a group of two or more equations. In this lesson, they're all going to be linear. When you're looking for a solution, we're looking for an ordered pair that makes all equations true. So we're looking for a value that's going to work in both or all of these equations. Let's start by how to check a solution. What we're going to do is we're going to take the values and substitute them into both equations. Both equations must be true in order for this to be a solution. Let's look at an example. Let's determine whether the ordered pair 3, 4 is a solution to this system of equations. So we're going to check if 3, 4 makes both equations true. So we're going to put 3 in for x and 4 in for y in that first equation. So 3 plus 4 equals 7. Yep, that's true. Now let's check the second equation. Y equals 3x minus 2. Put 4 in for y and 3 in for x. Evaluating that, 4 equals 9 minus 2. Well, that equals 7. That's false. This means that the point 3, 4 is not a solution to this system of equations. This week, we're going to be learning multiple ways to solve systems of equations. The first way is by graphing. Now, when we graph two equations, what we're looking for is where those lines intersect. If they intersect at exactly one point, there's one solution. We might have lines that are parallel. That means that there's no solution. Please make sure that you expand your graph and zoom out so you can make sure that you're not just missing the solution. Or sometimes you'll find that the two lines end up being the same equation. If they're right on top of each other, that means there's an infinite number of solutions. So let's go ahead and solve some systems of equations graphically. Now you'll want to use Desmos online graphing calculator for this. One great thing about Desmos is that you don't have to write these in y equals form. If you have a different graphing calculator you like to use, that should work as well. So we're going to solve the system y equals 2 minus x and 2x plus 4y equals 12. Go to Desmos graphing calculator and type both of those in. So in Desmos, I typed the two equations in at the left, and then I'm going to look for my solution as far as finding where they intersect. The nice thing is that if you click on that, Desmos is going to give you the exact value. So these intersect at -2, 4. That is my solution. So I can write my answer as an ordered pair, 2, 4. You might prefer to write it as x equals 2 and y equals 4, but you do need to have both of those values. Let's try another one. Let's solve the system of equations graphically. Y equals 3/4 x minus 3 and 3x minus 4y equals -4. Go ahead and graph those in Desmos. I've entered those two equations in, and it looks like they are parallel. I don't think they're ever going to intersect. I do recommend, again, that you zoom out, and you can double check. And yep, clearly these two lines are parallel. They'll never intersect, so there is no solution to this system of equations. Systems of equations are really great for solving word problems. Often the tricky part of these, though, is writing the equations. A movie theater charges $8 for a student ticket and $10 for an adult ticket. One Saturday, they sold 740 tickets for a total of $6,810. We want to find the number of tickets sold. We're going to have to write equations, but let's start by defining our variables. We're going to let X equal the number of student tickets. Likewise, Y will equal the number of adult tickets. Now this is a system, so we're going to need to write two equations. Sometimes it can be challenging to separate out the information. The problem basically gave us two pieces of information about this particular day. Let's look at one at a time. Well, the first thing I notice is that they sold 740 tickets. So for a minute, we're going to ignore the dollar amount. We're going to write an equation about the total number of tickets sold. If they sold 740 tickets, that means the number of student tickets plus the number of adult tickets is equal to 740. That's equation number one. For our second equation, we're going to ignore the number of tickets and we're going to look at the dollar amount. Now for the total dollar amount, we need to look back at the cost per ticket. It's $8 for a student and $10 for an adult. Well, if I want to find the cost of something, I'm going to multiply the cost of each ticket times the number of tickets. So $8 times the number of student tickets, which we said was X, plus $10 times the number of adult tickets, or Y, is going to equal my total value, 6,810. Now that we have our two equations, we'll go ahead and graph them. I typed these into Desmos, and I'm initially kind of concerned. It looks like they didn't graph. However, notice I'm dealing with big numbers. So currently, my coordinate plane only goes up to 50 in each direction. Probably I need to zoom out. I do that over here on the left using the minus. And one thing I can also do is I can hide my expression list. That way I'm going to get a bigger graph. Oh, and notice I have to go out quite far. But then eventually I do get my two graphs and I can see that they cross. If I click there, it is going to give me the intersection. So they intersect at 295, 445. Let's put that back in the story problem and see what that means. So the two equations we graphed, x plus y equals 740. 8x plus 10y equals 6,810. Again, we found where those intersected, which was at the point 295, 445. Now this is a story problem, so we probably want to explain what this actually means. You might want to look back at what you defined the variables, but what this means is that we sold 295 student tickets and 445 adult tickets. We'll continue to work with systems of equations in upcoming days and learn different methods. Please reach out if you have any questions.